we can do without. Yes, so I also at work on GHC, various things, and today we are going to talk about precisely that project. As you probably know, GHC is the most widely used. Oh, I know what the problem is. I need to focus the other window. Yep, there we go. Perfect. All right. Yeah. That is not forward. There we go. Perfect. So, as you know, GHC is the sort of dominant Haskell implementation. We are at the Haskell Implementers Workshop, although Leonard and others, of course, but have been doing great work on other implementations. I'd really love to be able to see, talk about other implementations more in this venue in the future. So let's hope that Leonard keeps pushing on his work. But I'm sorry?
Lightning talk later.
That's right. Yeah. We will hear more about Leonard's work. But in the case of GHC, we've been rather busy. So in the past 12 months, we've made 8 releases, and across no less than 4 different release series. And this is actually, there's some notable things here, right? So for one, we've had 9.6.7, and this is actually a bit of a milestone, because for a long, long time, over a decade now, GHC has been almost exclusively released by a small group of people, generally affiliated with well-typed, working on GHC maintenance, being paid by well-typed and our sponsors to do so. But 9.6.7 is the first case in a long time where we've had a release cut by somebody not in that set of people. That is actually Loita and his employer IOG paid for this work. Incredibly useful. They had a need for, they wanted to extend the life of that branch, and they put down the time and money to actually make that happen. That's really, really helpful, and I think it proves out that with the release infrastructure we have now, we can actually make releases in a more distributed fashion, which I think helps everybody. In addition, we've had a few sort of short cycle releases. So 9.8 is one of these. 9.8.3, we found there were some issues in the boot libraries that we shipped in that release. And within a month, we managed to turn around and ship a 9.8.4. Not as quick as we'd like, but nevertheless much quicker than we have had in the past. And so that's sort of, again, demonstrates that the infrastructure that we've been putting in place over the last few years has really helped us get releases out. With that out of the way, Andreas is going to tell us a bit about what happened in 9.10.
Exactly. Right, so let's jump straight into it. Linear types is a great expansion, language extension for safety, improved safety, and very much missing so has been support for let bindings, which in my mind makes the whole thing usable. If I might say so, this improves the ergonomics greatly. So I'm glad to have that development is ongoing, and I hope this continues. Then we have instance deprecation. So this will greatly ease the ability to future-proof deprecations. So you don't have to find out that things break completely when an instance gets removed. We can add a warning. You get the warning in your build.
Will we actually remove the foldable for tuples?
I wish.
You wish.
You wish. So,
Repeat the question.
Oh, the question was, will we actually remove the foldable for double? So there's the, I guess this would be a CLC proposal. Please open one. I would appreciate it. I've written length of tuple. Many other people have done it. I don't think it's helpful, but yeah. Okay, going on to the next one. Binding type variables. So now you can bind type variables that are through hidden for alls. Quite convenient. You can use them in the function body. In the same vein, we also have visible for all, which is greatly improves your ability as a library author to require people to put the type in the function call. So here we have an example for show. So it allows you to avoid the use of proxy, which is always a bit cumbersome in my experience when writing a library and when using a library. So you can just write the type itself. WASM backend. So in the WASM backend, now we have support for JavaScript FFI. So you can actually bind JavaScript functions that you have available, which makes the whole thing very usable. Like last year, Finlay, back then he was still my colleague, did a project using this feature, which demonstrated that very well, I think. GHC 2024, so this started with me not wanting to add bang patterns to every file. And then Joachim Breitner greatly expanded this ambition and did introduce the GHC language feature. And in the 2024 new, here's the list, but data kinds and GEDDs I think are very nice. The other ones as well, deriving strategies I think is very much needed. And the other ones on case-by-case basis, if you use them, you will no longer have to explicitly enable them if you use this language edition. Right, other improvements. There's of course info-table provenance. So this is a feature that allows you to have better stack traces. That was the word I was looking for. The problem with those has been that the binary size has ballooned quite a lot. So we added compression for that reduces that significantly. In GHCI, the load times, there were issues with the linker that caused very long load times on Darwin. There were similar issues, or are similar issues on Windows. We fixed them in master already. They are due to land and be backported as well. And object code determinism, my colleague Rodrigo worked on this. This is very nice for caching build systems. It hasn't been completely solved yet, but I think we're pretty close to actually have deterministic.
It's much better.
Yeah.
The master is like much closer than it was on that.
I think there's one bug outstanding to do with rules, but
That one's been fixed. I'm pretty sure that's been fixed.
that's even better, even better. Maybe you can do a lightning talk. And then we have 9.12 highlights.
All right, yes. So lots of great things in 9.10 and 9.12. More of the same. So we start with this, the conclusion, or at least a conclusion of this long-lived story. Many of you will, this will look familiar. This actually, the first proposal of OR patterns began was submitted in 2017. It is now 2025, last I checked. And we can now write this. And this is not quite what was originally proposed. This was a bit of a compromise. So you'll note here that we can write just of 42, just of 0. Neither of these bind any variables, right? And this was sort of the thing that was a sticking point that held this proposal back for quite a while. So you cannot write this with this iteration of this feature, but this is nevertheless, especially for things like enumerations and other wildcards, these sorts of things, you can get very far just with this feature alone. Multi-line strings, I think, is something that we've all been missing. Many languages that we all also are exposed to, for better or for worse, on a day-to-day basis, support multi-line strings. We can now count Haskell in this group. So this is a Nix style or Python style multi-line string, and again, something that a lot of us long wanted, but it still is sort of a hole, right? We still, in Python especially, I know that when I am forced to use Python, the string interpolation syntax is just chef's kiss. And this is something that there is also a proposal, which is not yet accepted, but is ongoing, discussion's ongoing. We really would like to, push that forward. I know there's a prototype implementation, and discussion is sort of coming to a conclusion. So if you have thoughts on this proposal, please do bring them to the discussion. And hopefully, this time next year or soon thereafter, we can say we also have native string interpolation support. That would be really great, in my opinion. Finally, this is another thing, long-standing task. I remember I don't even remember, Simon Marlowe in 2000, it might have even been, the next digit might have been a 0, actually. HIW gave a talk, why can you not get a backtrace? And this has been the case for a very long time. That Haskell, when your program does fail, rare as that may be, you really have a hard time actually pinning down why. Exceptions in particular can be quite difficult to trace. No longer is this true. So we've gone through a few iterations of this various idea. This was about 3 or 4 years ago, I think, that I submitted the first iteration of this proposal. Very ad hoc. This is a case where the Core Libraries Committee process really helped pin down a really nice sort of the core of the idea, I think. And I think Vlad, who was the shepherd, helped a lot in actually honing this idea. So we now have this ability to exceptions now carry context, right? Which is a dynamically typed set of annotations, or a set of dynamically typed annotations, I should say, in much the same way that you have the dynamic type. or the exception itself, right? Is some exception is dynamically typed, existentially quantified over a concrete exception type. And the idea here is that if you have, for instance, a server application is handling some requests have IDs. If I have a request that fails, it can be very useful to know, like, well, for instance, what was the request ID, or what various contexts might I want to attach to the exception that I can then log and preserve in structured form, ideally. And this annotation mechanism actually allows you to do exactly this, right? So under this annotate IO, we can perform an IO action, and any exception that IO action throws will have this annotation attached to its context. And this is, of course, quite useful itself, but then we can extend this idea and say, well, backtraces. Backtraces are just another form of annotation, right? So when we get when we see an exception, we can then capture a backtrace, using any of the various mechanisms that GHC has grown for capturing backtrace information over the years, and there are quite a few of these options now. If you're using profiling, you can use the cost center stack. If you use has-call stack, as is increasingly common in library code, you can use the has-call stack and backtrace. Execution, this is the dwarf execution stack, or IPE information, as Andreas has mentioned earlier. And this is actually one of the reasons why we've been focusing so heavily on IPE information. So we really want to make sure that it is usable as a sort of first-class first option. The first thing you reach for when you put in an application into deployment is IPE. You want to compile that with IPE information, and then you can enable IPE information, the IPE backtrace mechanism, and you will end up with hopefully usable backtraces in your exceptions. So by default, out of the box, you'll only get has-call stack backtraces, but again, there's a function you can use to enable and disable these various mechanisms. Yes?
So this IP information, is that only something that affects the final executable? So is it something that could be enabled by default for all library, or does that carry a cost?
Repeat the question.
Repeat
the question.
Of course, I will. So yes, the question was, is IPE information something that only affects the final executable, and what costs does it imply? If I'm not mistaken, right? So the question, the first half of that question is answered by it will affect all compilation. So if you compile a library with IP information, that will any object code that is emitted will, when you enable IP information, have additional information, a set of metadata, the intro table provenance table particularly, which then is going to, of course, require that it blows up your code size, right? And that's the answer to the second. And that is considerable, right? There's a lot in the way of the same. If you compile with -G and a C program, for instance, that tends to explode your code size pretty significantly. For that reason, many compilers or many distributions will actually split debug information out from the executable, allowing you, so you have the executable and then a separate file with debug information. We are actually, Matt has been thinking about how we might consider doing this for IP information as well, because it is actually considerable cost in size. Yeah.
So the only way that you see the performance hit is because of CPU caches?
So the question is, what is the runtime cost of using IP information? And the answer is actually none. So there's potentially a cache effect, but even that is actually quite unlikely because of how this is laid out. It's actually quite well separated. The IP information quite well separated from the actual code. It does not affect the text section of your program at all. The actual code generated.
So final question, is all the base libraries shipped with this IP?
So which libraries in the GHC distribution ship with IP information? The answer at the moment is none. That is something that we want to address. That is, and there is a question here, and I think this is as much a distribution question as it is a GHC question. And it's something, one of the reasons why split IP information would be nice is we would be able to offer IP information as a separate sort of add-on installation, add-on package through, for instance, GHC Up. and that would allow one to then add IPE information for the core libraries to an existing GHC installation, which I think would make for a nice user story. But there's a lot to be discussed there. I'm hoping to discuss this with Julian, in sometime this weekend. Right. So that's IPE and backtraces. Lots of exciting things happen there. But that's not all, right? We have various improvements in code generation. We have a few new backends. So RISC-V, Sven Tenney has been working on the RISC-V backend. This has been great. Moritz Angerman as well. And we have, of course, China the Chinese government has been putting a lot of resources towards a domestic semiconductor story, and they have long been supporting Longsun, I think is the name of this company, who has this architecture based on MIPS, I believe, called Long March. This is they actually have been funding some work to both already in 9.12 we had unregisterized support. In 9.14, we will have good LLVM backend support, and they're actively working towards a native code generator. It has been merged, actually, but I think there's probably more to be done there. And even perhaps as exciting, another long-lived sort of story, the SIMD support, which was introduced for the case of the LLVM backend in early 2010s, I believe. We now have support for these instructions, these operations, in the native code generator, which is sort of one of the things that has held back usage of these operations for a very long time. If you can only assume that they're supported in the LLVM backend, then you can essentially not assume they're supported. This is now, with native code generator support, in a few releases, hopefully we'll start to see usage pick up a little bit more. And even Sven is working on adding support in the RISC-V backend. We do need somebody to handle AR64. Neon is still an open question. That's the AR64 SIMD instruction set. Again, we'd really like this support to be broad-based so people can just assume that these operations are available. Sam has also been working to add new instructions, new operations. We have named defaults. If you use text, you'll of course, be familiar with the problem of ambiguity of string literals if you're using overloaded strings. This is a way of dealing with that problem. If you have a prelude, you can then add a default declaration, which is then going to say if you need to solve for isString, first try text, then try the string. And that's something that you can then export, and that will be applied to any module that imports it, which is a really great feature. And, of course, this is just 9.12. We have a 9.14 release coming. Yes, of course.
About RISC-V and SIMD, are you referring to the vector extension?
In the RISC, sorry, repeat it one more time.
About RISC-V and SIMD, are you referring to implementing the vector extension for RISC-V?
Yeah, so the question, in the case of, going back a few here, yes, Sven's work on SIMD support in RISC-V. You will actually, I believe Sven has a talk about this later on today, but the question was, what in particular instruction set extension was he targeting? Yes, I believe that's a vector, the V extension. But you'll hear more about this in just a couple hours, I think. So I'll let Sven cover that. Right, so we have quite a bit of work in the pipeline. Explicit level imports. Do we have actually there we go. All right, explicit level imports. This is something that we're at Matt Pickering, really improving our story for separating compile time from runtime dependencies with effects on both compile time, the actual amount of work we take necessary to compile code, as well as how easy it is to potentially cross-compile. We have, again, in that direction, template Haskell support for the WebAssembly backend. This is work of Cheng. So really making WebAssembly a first-class target. We've had a variety of work recently on the GHCI debugger, which has been kindly sponsored by Mercury. This is something that my colleague Rodrigo is currently working on. We have step out and step in support. We have worked on a debug adapter protocol sort of front end for this. So you can use the GHCI debugger as though it's an interactive, like you would GDB in VS Code, for instance. And then various work on improving the interpreter performance as well. We have ARM's AR64 support for Windows, which the very brave contributor Sergey has been working on. Really impressed by how quickly he's brought that up. Various work on improving cross-compilation, and of course we have the backend, the Loon backend. Matt has been working on multi-home unit support, which is something that Hannes. I stand corrected. Hannes is now working on multi-home unit support, something that really critical for making HLS work in project-based settings, string interpolation syntax, and of course, I'm sure somewhere in this group somebody has something that we've not yet covered here. This is your opportunity to speak up. Does anybody have anything to add here? Not either for 9.14. Which is, we've not been particularly great in advertising the status of 9.14 yet. For the record, it's going. We hope to have this forked by next week. It's not clear that if you have not yet merged, then be in touch. But I've been a bit remiss in advertising that fact. However, if there's something that you'd like to see in 9.14 or have in your cooking for a later release. Open the floor.
Bytecode architect.
Ian?
First class bytecode architect.
Yeah, right. So another thing that we're working on in sort of this bucket of work here, the GHCI bytecode interpreter improvements work, is making bytecode also a sort of a first class object format, if you will, something we can preserve across and reload without recompilation. Again, improving the cycle time, iteration time when using GHCI.
Record updates.
Record updates. Okay, you'll have to maybe a few more words.
With the dot syntax.
Oh, dot syntax. Yes. Record updates using dot syntax.
Yes.
Quite right. Yeah, dot syntax is we of course. I think that was 9.8, 9.10. I can't remember.
I don't remember
Yeah,
either.
it's supported for 2 releases now, but updates aren't really possible. That should be that's something that will be addressed. I'm not actually sure who's working on that currently, though. Alan.
I'm working on the GHC CPP implementation.
Oh, great.
16 and beyond.
Yeah. Okay, so that's actually a really again for HLS and similar tooling scenarios. Currently, the CPP extension can be quite problematic for sort of your IDE tooling. Alan has currently a proposal working towards making CPP a restricted form of CPP, but nevertheless a useful one for most settings. A sort of first-class set of constructs that the parser can understand and explore multiple paths through that, making it a sort of proper conditional compilation, proper conditional compilation story.
And to talk about it later.
And there's a talk about it later, so I don't even need to say any more. Excellent. Anything else? Cheng.
The GHCI browser mode for WebAssembly.
GHCI browser mode. Oh, I don't even know about this. Okay.
Yeah, so it allows you to run GHCI for one backend, but it runs in a browser, so you can have access to the DOM and all
Oh, wow.
that kind of stuff.
Oh, that's great. Oh, fantastic. So you can see the WebAssembly. You run GHCI in your browser and get access to the DOM, etc. How are we doing on time?
Oh, we have 9:37.
Oh, great. Yeah.
Namespace specified imports. So, explicit namespaces. You can say if you want to import a type operator as opposed to a normal operator, you say type in the import. You also have this problem in infix declarations. You have to say if it's a type operator or a normal operator. And in warnings, warning pragmas, everywhere you have to specify imports. So now we have type and data, 2 keywords, to select which one you want. For 9.14 and for 9.16, we will add wildcards, so you can say all of the type names or all of the data names in a module.
Oh, wow. Okay, so that is working towards allowing you to say in a qualified manner, say all things at the value level I want to export, for instance, or all things at the type level, using the sort of data and type qualifier keywords that you can currently use in export list. There's one other hand I thought that I didn't catch, but okay, maybe not. Great. Okay. Well, yeah. So as you can see, lots of things going on currently, yeah, 9.14 is, especially the WebASM stuff, sounds great. That's going to be very interesting. I'm looking forward to playing around with that. So I think was this?
Yeah, sure.
Great.
Right, we're coming to the community update section. So GHC is not about just the source code, but also the people contributing, the people using it, people distributing it. So we have the GHC proposals process, which allows people to suggest changes to GHC, the language, and things related to that. And in this year, we had 2 proposals accepted: explicit level imports, which allows you to disambiguate compile time and runtime imports. Import shadowing. Import shadowing was allowing you to use a function defined in your current module, even if you import something with the same name. So you don't no longer get an error about ambiguous binding names. We had somebody mention this yesterday.
Finally.
Finally, you can use ID as a name. So then the next thing is some stats about contributions to GHC. So I have we have the commits, which is number of contributors per year, grouped by commit count. So one thing that when we looked at this data, we noticed is there's a distinct downwards trend, I would say, for recent commits. So I have had a theory about that. So we looked a little bit more into the data, and we looked also at tickets for the first time this year, which is number of users opening the nth ticket per year. So if you just look at the blue line, that's basically a person has opened the first ticket on GHC this year. So I don't think there's too much reason to panic, maybe a tiny bit. Because one thing we did is that in 2023, I believe, we were so swamped with spam registrations on the GitLab instance that we had to switch our sign-up method to manual verification of users. So people have to reach out to us, have to contact someone to get their account verified, which is a huge step, right? Like, very few people are actually committed enough to do this step, and I think personally that this is the main reason why this graph looks like that and why it's so extreme. So I think...
It should also be made clear that the 2025 number is actually, that's half a year or less.
Yeah, the last data point is not quite complete.
It's not, yeah, that should
So look at it like this.
Yeah, exactly.
But yeah, I think it's really time for us to do something. We are not quite sure. Maybe we'll return to the track model. So it used to be in the past, if you went to sign up, the website would give you a string, you paste it in GHCI, you get an answer, and then you copy-paste this into the website, which I think is a lot more accessible.
Could the reason not be that you've just fixed all the bugs?
The question was, could the reason...
Slide, I think.
Yeah. But just to repeat the question, it was, could the reason not be that we fixed all the bugs, to which I have to say no. So this is the number of open tickets and old tickets that have been opened. And so we see the same trend continuing. People use GHC, they find new bugs, they want new features. And there's just an ongoing process there. I think it's not too bad. It's not as bad as it makes it look here with the number of open tickets. That doesn't mean there's not important open tickets. I know there's like some tickets about profiling crashes in 9.12, for example, that I'm going to work on in the near future.
The gap is growing, so we're fixing a lot of them.
Yeah, we are fixing a lot of bugs. That's very true. And I picked one random example. So there's a lot of tickets. People have good ideas. 18 years ago, automatic heap profile intervals. It would be nice to have, right? But it never quite makes the top of the list for us to implement. So if you want to get your hands dirty, tickets like this, there's a huge number of those. And you can go wild and make your own mark on GHC. So,
Are they labeled?
many are labeled as newcomers. We have a label for this. If I just go back. So there's on the GitLab instance, we have a label for newcomer tickets, which is tickets we assume someone can work on without prior knowledge. Not all newcomer tickets are labeled as newcomer. Sometimes we just misjudge them or something. Sometimes also in the reverse, but we are willing to help. But yeah, and there's a lot of tickets, I think, that might turn out to be simpler once you actually look at it. But I don't want to discourage anyone. Take a look, right? So moving on. So AI has been an ever-growing topic in recent times. So we thought about AI contributions lots of people started generating code using AI. And I think it's just a better practice instead of just hand waving the topic to have an explicit policy about that. For GHC, currently we're leaning towards just saying it's fine. If you come up with a good prompt, you understand the code that comes out of your tool, that's okay. Maybe you generated 1,000 tests and they're all very mundane. That's all right, right? Maybe you just do the trivial refactor using some AI tool. That's also all right. So we don't want to rule out this kind of AI contributions categorically. You should understand the code that comes out. We don't want someone to feed GHC into a black box and put up an MR, and then we ask them, oh, why is this change here? And they go, I don't know. That's not the goal here. So we put forth a proposal in this ticket with one way how that could look. So if we invite everyone to leave their input there. We haven't made a final decision yet, but currently, we're leaning towards allowing this.
Right, yeah, so in the past 5 years, GHC, Haskell.org more broadly, and GHC in particular, we have a lot of infrastructure, right? I mean, a lot of it goes unnoticed, and that's a good thing. We don't want our users to have to worry about our infrastructure, but it has to be hosted somewhere, and for the last 5 years or so, much of it has been hosted via Equinix, formerly a service known as Packet, and they've graciously provided us with literally tens of thousands of dollars in hosting, probably over $100,000 at this point in free hosting. And they really deserve acknowledgement for that. It's really amazing just how generous they've been. And so this has hosted everything from the things that you interact with on a day-to-day basis, like Hackage, to our GHCI services. Oops, sorry about that. There we go. Google, the Wiki, Discourse, all manner of things that we come to rely on, have a box or are hosted somewhere on Equinix, and that's great. Unfortunately, all good things have to come to an end, and in this case, Equinix, they did not say this had nothing to do with us or open source even. They just wanted to turn down the Packet product, the bare metal hosting solution that we were using. They're no longer going to offer. And so, of course, that means we needed to come up with a alternative, right? We needed to have some migration strategy to make up for that hole. And that was something that we started in February, and ultimately came up with sort of a hybrid solution. The high availability services, namely Hackage, ended up on DigitalOcean, and most others ended up in Massachusetts at this really great little local co-location facility called Open Cape. They've given us a really great rate for their services, and this is all paid for by the Haskell Foundation. So if you are anybody in this room who has donated or his employer sponsors the Haskell Foundation, this is what your contribution is going towards, right? This is one of the many things the Haskell Foundation is helping to ensure goes addressed. So this is something that we started the technical work. Of course, this was a considerable effort, not only because of the number of services, but because many of these services have just been running in the background for, in some cases, a decade, with minimal maintenance. Some people, there's loss of institutional knowledge as people pass in and out of the community, and so there's a lot of refactoring and sort of figuring out what it is that we had and how to actually make it more maintainable in the future. Did a lot of nixification of these services, a lot of consolidation, and I think that the work that we ended up doing was really great. We finished by our deadline of May 1st, and we, for the most part, have a really great maintainable set of infrastructure now. And the great thing about that is now we are in a situation where things are documented well enough and are clear enough in their implementation that we can actually potentially open up these responsibilities of maintenance, administrative tasks to a broader group of people. For a long time, Haskell infrastructure has really been the work of a few, literally 2 or 3 people. Gershom really deserves some acknowledgement here. Brian has helped out a lot, and Davian. All of these people were really instrumental, especially Davian, in the social aspect of the migration, trying to figure out who is going to give us what sort of resources He helped a lot in the DigitalOcean, getting our agreement with them, and helping to get the Open Cape situation sorted. So he did a lot of really great work, non-technical work, and that I think really deserves calling out. But as well, Gershom did work in migrating the package, Brian stackage, and there's generally been a lot of. I think we're in a much better position than we were in 6 months ago, especially because we're no longer beholden to donations now, in-kind donations for our hosting, which is always kind of a precarious situation, as we know. So, and all of this is possible because we have now a pretty diverse set of people who are donating, contributing in kind and financially to GHC maintenance, the Haskell Foundation, Haskell.org. All of these are things that require resources. And so in particular here, I'd like to call out just the GHC aspect of this. So we have Cubase Logic, Just Play Mercury are all supporting our work at Well-Typed. We have the Haskell Foundation, who's supporting us via Brian, as well as a ton of enabling work that Jose has done. And then Tweak and Well-Typed also support Haskell Foundation, as well as GHC development directly, IOG. Similarly, this is only a subset of the people we have. So really, these people all deserve a bit of a round of applause, if we could. And one of the things that the Haskell Foundation in particular has enabled in our community is really serving as a sort of clearinghouse of ideas, right? We have finally a venue in which to discuss all of these inter-project and especially user-centric ideas that issues in many cases that previously went unnoticed or undiscussed. And so in this case, GHC's release practices have long been sort of both underdocumented and a bit ad hoc. So this is something that we, last year, as a result of a survey that we put out, started to address. We went on to discuss our concrete packaging policy and release policies with a variety of individuals, stakeholders, and that led to several iterations of a document, which is now our formal release management policy, which includes things like how we version our releases, the communications, where and when we will communicate, timing of releases, what things we can our downstreams can expect with respect to platform support. And this was a really helpful exercise, I think, for both sides. It really sort of helped set expectations and put us all on the same page. And I think Jens Petersen and Julian Oswald in particular, Adam had some really great, Adam Gundry, my colleague, had some great input. There's really a lot of really great discussion that happened as a result of this process, and I think we're all better off for it. So, I'll bring this over to Andreas.
Right, release schedule changes. So there was once again a big discussion in the community about release schedules. I will start with the bad thing that some people have hoped for. Currently, there are no plans to release less frequently when it comes to major versions. But I think it's time that we should consider designating releases as with a longer support window, do some sort of LTS release ahead of time, because as we've heard yesterday, especially as well with the not so boring Haskell talk for those who were there, like it's just, there's this ever-growing cycle, people wait to upgrade, then eventually they decide to upgrade because they have a confidence in the release, and the release cycle for this release is about to end. And we hope that the details haven't been quite figured out. I think this is the perfect time to get a feedback on this idea. But if we designate the release, let's say 9.14, it's not decided yet, but just hypothetically, as a long-term release, we would hope that more people are more willing to upgrade earlier, we get more feedback earlier, we can fix the bugs while you're still using the release, and you don't have to hope for one release where the bugs that affect you to have been fixed without new releases having occurred. So there have been discussions in the past in the ticket in GHC 25496, and the recent discourse discussion was on 26067. So I don't think we have to get into it too much right now, but if you have opinions on this, approach me, approach Ben. We're willing to talk about this. We want to hear what people think. This will probably, if we do this, probably come with a little bit of a shorter release window for the non-LTS version, so to speak. And we will also
Support window.
yes,
Yeah.
and we will. It's also to be seen like how long can we actually make a release window. So GHC is a project. We have never tried to keep a release going for a very long time. I think 9.6 might be one of the longest lived releases currently, which was 1.5 years or something like that.
Even longer than that, but yeah.
So we will see how it goes, but I think this is a step in the right direction. And assuming the feedback is good, we will likely end up doing this. Last but not least, how can you help? GHC, again, is not just about the source code, it's about the people interacting with it, contributing to it. So there's, especially in the compiler, there's many areas where we could use more hands. There's always more things to do than we can do if you think back to the ticket graph. There's the various backends. If you have an interest in code generation, we have the ARch backend, we have the RISC-V backend, we have JavaScript. Even x86 isn't perfect. Even if you want to improve the x86 backend, there's still open tickets with ideas that are implementable by someone who has the spirit to dive into this. Similar in the front end, there's always things to improve in the type checker. Arrow desugaring is a long-standing SOA point. Documentation issues. Documentation can never be good enough. We all know that. Headocs as well for the inline documentation. Headoc as a project itself now lives as part of the GHC source tree and is also chronically short on manpower. Compile runtime optimization. Personally, I think this is one of the most interesting parts of compilers, and there's an infinite amount of things to work on in this respect, and the list goes on. So if you have interest in something, reach out to one of the people on the GHC team, one of the existing contributors on the channel and the Matrix. Let us know, and we will try to get you set up so that you can also contribute. And I think that's it. Thanks.
Thank you, Ben. Thank you, Andreas. We still have plenty of time for questions if there are any.
Matt?
I just, it's a thought. If there is an LTS release, it might make sense to have that as like the 10.0 release, and then each LTS is 11, 12, 13.
Not a bad idea.
Yeah, just a thought, I'd say.
Yeah, I like it.
Yeah.
Oh.
So the idea, the suggestion was, if we go this LTS idea, it would make sense to designate these as super major releases. So we have been on GHC 9.x for a long time. Maybe the next LTS could be GHC 10.0. Seems like a sensible idea.
Yeah.
In that case, it's a bit dangerous to introduce all new features into the first LTS release.
Yeah, so the point was that there is a sort of tension between introducing new features into a release and it being an LTS release. And I completely agree with you there. I think that's...
Nobody uses 0.0 releases.
Yeah.
Yeah. Well, I will just answer that or add to that. Right, there will be point releases for an LTS release where we can fix bugs in those features. Many features don't necessarily interact that strongly with the existing parts of the code base. Maybe we put not the most dangerous features into an LTS release, but yeah.
But LTS means long-term support. How often have features been deprecated? So
Not often enough.
So the question...
Basically, they are supported for a very long time, so LTS no more applies to new features because they will be supported
So the question...
from that release onwards.
So the question was basically, typically features in GHC have been supported almost forever. There's a few exceptions, so it seems apt to even include new features in the LTS release. I don't disagree too strongly with that. I think it needs to be handled on a case-by-case basis.
Maybe making the last release and be making it LTS. So for example, 9.14 is going to be the last, and then going to be 10. And 10 introduces a lot of features, while the very last 9.x version is going to be long-term support.
So the question was if it would maybe make more sense to make the last version of a super major version, that's for example 9.14, the long-term version, and then have a fresh 10.0 version where we add the new features.
And break people's code.
And break people's code, hopefully not, but that's what was said. I'm not sure it's another option to go about it. Something to consider.
So LTS, does it mean longer backport window, or what does it mean?
So in my mind, this means the question was LTS, what does it mean? A longer backport window, for example. And I would say yes, that's the main idea, right? That we don't currently, at some point, we cut off the branches after like a year or a year and a half and stop doing backports and new releases for this branch. And the idea would be, yes, that we have one branch that is longer and has more backports. Like if 9.6 were to have been an LTS, maybe we would say in like 6 months from now, we would do one more backport if we find critical bugs. Yeah.
Two questions. Are you planning to release binary distributions for RISC-V? And also, since it was mentioned, what is the state of the package metrics builder?
So there were two questions. Are we planning to release binary distributions for RISC-V? And what is the state of the package matrix builder? I can't say anything about the package builder, but for RISC-V, so typically GHC has different tiers of platforms, where for tier 1 platforms, we try to do releases. I will not list them all now. RISC-V currently is not one. So there would have to be someone would have to step up and do a binary release for RISC-V. This could change, right, based on popularity and funding. For example, if a company steps up and says they want to fund a RISC-V as a tier 1 platform, then of course we would also be willing to do a binary release.
One of the challenges there is that we would actually like to be able to build these releases on actual hardware. You know, emulation is great. QEMU is a great tool, but you know, if we're having certainty that there is we're building something that's usable on actual hardware, it'd be good to build the thing on actual hardware. But there is actually not a whole lot of hardware that is capable of this at the moment. That is, I think this is probably something that we can discuss during Sven's talk. I think it's probably a good venue for this. With respect to the package matrix builder, what is the status of that? Is at the moment orphaned, as far as I'm aware. Nobody is actively working on it, unfortunately, for better or for worse. I mean, I think there's a lot of potential in that idea. The implementation, there's a good foundation for somebody to pick up if somebody does want to work on this project. For those who aren't aware, the Matrix Builder is essentially a service that was building combinations of packages on an ongoing basis and reporting their buildability and essentially, you know, when you the promise it held was when somebody uploads a new version of a dependency of your package, you could in principle be informed that, oh, well, there is a new version of this dependency in your package builds. Maybe you want to consider actually bumping the bound, or you know, something along these lines. Nobody's working on this at the moment.
If someone did resize, would there be kind of hardware to run?
I missed that. Sorry,
if somebody were to pick this up, is the hardware to run it? Was the question?
Oh, we could make that happen. Yeah. I think that's definitely the problem at the moment. Is the person, not the infrastructure. Let's see. One of the things that I actually neglected to mention during the talk that I want to quickly bring attention to is one of the few things that we've not yet sorted with respect to the migration is ARH64 Linux. That was an area where Packet was particularly helpful. They gave us a very large server class ARH64 machine that served as our primary CI runner on ARH64 Linux. This is no longer available. We moved to Azure. Azure has since notified us that they too are going to be turning down their open source program. So we at the moment, as of August, don't really have a strong solution for AR64 Linux CI support. We are talking with HF to maybe see if we can acquire hardware of some variety or sponsor cloud resources. But that's something that is still an open question. And if anybody has leads in this area, knows of either a source of hardware, a source of cloud credits or similar, let us know. That would be really helpful.
That service that I mentioned that you can co-locate boxes.
Yeah, so that includes, so the question was that, just mentioning that we can in fact co-locate boxes. We have hosting capacity for physical boxes. Jose, maybe?
Yeah, so just for context there, the current first choice is to get a box for this that we will put in Massachusetts with the other boxes. So that's like kind of our preference. So if you know of someone who wants to donate an ARM server or something, that would be stellar, right? But the HF is currently pursuing that as option number 1, with cloud stuff being option number 2.
Yeah, so we're working on trying to procure hardware, co-locate.
Linux hardware as well.
Sorry?
We want some Linux hardware as well, don't we?
Yeah, then we potentially, we don't actually know yet. I mean, that's something, we're in discussion with Lund as well. Maybe there might be some option there to get them to either host or offer us hardware for their own architecture. There was one other hand back here. I'm not sure.
I had the same question.
Okay, great.
With regards to tickets, how many of those are stale or sort of, is it sort of guesstimate as to how many of those are things where you would just follow up on with like 2,000 people and just say, you made this in 2016, do you still care?
So the question was how many tickets are basically have gone stale, are no longer relevant, the person doesn't care about the ticket they opened anymore. It's hard to say, like I find tickets that are relevant all the time, sometimes from like 17 years ago or something, only very recently.
I've noticed the same thing, so like, it sounds like it
like this one.
Yeah, I think there is a decent amount if you just go like ticket by ticket. There is a decent amount of stale tickets. Matthew Pickering in the past actually went on a kind of a heroic effort to close tickets. I think this is this bump here. Where he closed, I think this is like 1,000 tickets or something that he closed.
I think that was just after I started working, so I was very keen.
Yeah, I mean, Matt was like, he's going to clean up the ticket system. And eventually, I think he ran out of steam. But
if you have energy for this sort of thing,
yeah.
like curating our ticket collection, that's also another really valuable contribution.
Part of the problem is you kind of have to know if it's no longer relevant, right?
Yeah. So
like
you want an expert, right? Someone who's
yeah, well, at least familiar with the topic, and you know who to ask and things like that. All right, one more question?
Yeah, this is more for the GHC proposals team. Like, how do they decide which proposals go up for a vote to the community?
So the question was for the GHC proposals team, how do they decide which proposals go up to a vote? Was it for the community?
Yeah, like the OR patterns was
right.
a community vote.
So OR patterns, he said, was a community vote. I don't actually know. I'm not sure if you know, Ben.
I'm sorry. No,
I can answer that question.
Great.
There is no such process. There is no such process in the GHC steering committee as putting something up for a community vote. It's something that the proposer, on an individual basis, can organize and then present the committee with the results of the community vote.
Okay.
But the end decision is on the committee, not on the community.
Oh, okay.
All right. What other? I think we have another 5 minutes actually.
Okay.
If there's further discussion, we can.
Anything you want.
Time. Yeah. I mean, anything from sharing release thoughts on the release process. That's certainly always a point of contention.
Start that now.
Yeah. Maybe that's not a wise thing to go down.
Doesn't have to be anything we talked about. If you have a question, just GHC questions outside of that are also fine.
One of the things we didn't touch upon in the talk was that the CLC and ourselves have been within the GHC project have been actually trying to be increasingly aware of breakage, and there's been a lot of work done in this area. We've been trying to cull or at least stabilize base. That's something we discussed last year. We've now moved the implementation, a lot of the implementation details of our core libraries into a new package called GHC internal, which you're explicitly, as a user, not supposed to depend upon, which then gives us the ability to decouple interfaces from implementation, which has been really helpful for us in sort of drawing these distinctions. We have a GHC experimental package, which is intended to now expose the things that the CLC and we deem have not yet stabilized sufficiently to sort of warrant inclusion in base, which is intended to be a stable interface. So these are things that we hope, and I think evidence so far is suggesting this is the case, will ease migrations across GHC versions. Michael.
I was going to ask, what's the status of reinstallable base?
What is the status of reinstallable base? That is a really great question. So at the moment, there has not been a lot that has happened. The GHC internal refactoring was one of the prerequisites for that effort. At this point, there are a few tricky questions to do with how we deal with template Haskell in particular, which Teo has been working on resolving and has made some excellent steps in that direction. And I think at this point, we may actually be in a situation where we can, again, look at this, because this actually dovetails nicely with the other question. For those who don't know, one of the ideas that we've had for mitigating the effects of breakage in base on users is allowing users to depend upon older versions of base or older interfaces with newer GHC versions. Right? So if you have a package that built with GHC 9.8, you want to build it with GHC 9.10, well, okay, very well. Then we will simply use the base release, and that is to say the interfaces provided by GHC 9.8, and build with 9.10. Right? And that's something that now, since we've decoupled implementation from interfaces, that's something that is in the realm of the possible. So that's, however, there's the question of what do you do in the case of Cabal, which insists that you have a given install plan has a single version of each package, right? So if you have a dependency library that requires base from GHC 9.8, and you want your package to depend upon base from GHC 9.10, that would, under that rule, under this one version rule, pose a problem. That is something that we've actually done some work within well-typed in a more recent project, unrelated to reinstallable base, to lift, potentially. We have the ability to talk about multiple versions within an install plan now. Matt is actually...
It's a bit overcomplicated.
Yeah.
Base is reinstallable in principle now.
Yeah.
It's not wired into the compiler.
Well, right.
Or maybe
the user experience story there is tricky. That's kind of the problem.
Maybe that's sufficient.
maybe to summarize, right? Like in terms of the compiler support, the foundation has been laid, but there's a lot of tools that have to be updated and adjusted to make that a usable workflow.
Okay.
Maybe let's leave the rest of the discussion for offline, so we
that
have
up
to
later,
switch
yeah.
over with it.
Good question, Michael. We should have discussed that earlier. Thank you very much, though.